Thing. Hey everybody, thanks for joining. I'm going to be going over software supply chain 101, more or less what are software dependencies, how to understand them, how to use them effectively, and then we'll touch on just sort of overall supply chain security. So I've been working in supply chain for almost a year now, and it's just amazed me that there's so many people who I think are 100x smarter than I am. People on the program analysis team, people who have been working as developers for decades, but they don't really pay close attention to supply chain. So quick background on myself. Currently a security researcher at Semgrep, been there for almost a year now. I'm also the founder of CramHacks, which is a weekly newsletter focusing on software supply chain security, posting things like tooling, open source tooling updates, just ongoing news and events, regulatory requirements, or federal guidelines, things of that nature. So I'm finishing up my master's degree in computer science at Georgia Tech, which is fitting for Atlanta OWASP. However, I'm not based in Atlanta. I'm actually based in California currently, but I'm a part of their OMSCS program, which is incredible. If you haven't heard of it, definitely suggest taking a look at it. I think the full master's degree, for example, is going to cost me about $6,500 out of pocket. And the acceptance rate is much more friendly. So that's how people like Kyle get in. I also have my bachelor's degree in information systems from Stony Brook University, which is based in New York, which is where I was born and raised. And my background is primarily in InfoSec. I'm doing a lot of penetration testing, incident response work, malware analysis, threat intelligence, stuff like that, specifically for financial institutions around the US. So I have the alphabet soup, CISSP, OSCP, GWAP, GCIH, SecPlus. There's probably others that I'm just have forgotten about at this point. But as of late, my research is hardcore focused on software supply chain security. Let me just move this little box out of the way. And so as far as the agenda goes, I'm going to be focusing on software dependencies and what they are, some fun facts about them, and then why they're a nightmare sometimes, which leads us into dependency management, build reproducibility, which if you're not familiar with that, this will be a very worthy presentation for you. Virtual environments, how to use them, how they aid in build reproducibility. And then we'll go into a pip env demo. So for you Python developers, you might be able to learn a thing or two if you're not already familiar with it. And then supply chain vulnerabilities, just some basic trends, what reachability is using software composition analysis. You might have heard that referred to as SCA. And then a quick touch on Semgrep, which is a open source static code analysis tool, but we actually use that for Semgrep's supply chain product. And so I'll show you how you can use the Semgrep open source engine to do more or less what we're doing with the supply chain product. So quick disclaimer, I do not know everything. I actually almost always tell people that I have an approximate knowledge of many things, which is hilarious because I only recently, like actually very recently, learned that that's a direct quote from Adventure Time, which is a cartoon show that I actually don't really watch. But that was good to know. But it kind of goes with the whole, I have an approximate knowledge thing because I knew the quote, but I had no idea where it came from. And so until I found out it was mine. And so for the sake of the presentation, I'm going to primarily focus on PyPy as a package manager. So just sticking to the Python ecosystem. I can try to answer questions about other programming languages and their package managers, but I can't guarantee I'll be 100% accurate all the time. And so I guess really what is a software dependency? And so I have this analogy, which is basically, imagine you're writing a letter and you need a pen and a paper. And so in programming, if you're writing an application, you will lean on software dependencies to add functionality. So rather than going outside and cutting down a tree and turning that wood into paper, you can just go to the store and buy some paper. So that's like, as a developer, you can just go to the package manager and install a dependency, and now you can make direct references to that code, so that you don't have to write it from scratch. There's oftentimes things you do have to often add functionality or add some checks, and you have to do stuff with it. You can't just buy the piece of paper with the answers written on them. You have to sometimes fill it out, but they do assist developers significantly. And then another interesting point, so the pen needs ink, right? So there's direct dependencies, which would be the pen and paper in this instance. And then there's also transitive dependencies, which you can think of as like third, fourth, fifth party dependencies. And so for this example, that might be the ink that goes inside the pen. And so the first Python package that I ever really worked with and always stands out to me is the request package. You may have, for one reason or another, have wrote socket connections and communication for GET requests or POST requests. It's not fun to do, especially when you can just do like literally 2 lines, import request and request.get, to make to force a GET request to a URL, for example. So what you're looking at here is a GitHub snippet. So if you go to any open source project, or really just any project in GitHub, you can go to the insights page and you can look at dependencies and dependents. So dependencies would be what dependencies does that project rely on, and dependents would be what projects rely on the project you're looking at. So if you go to requests, you'll see that there's almost 2.5 million repositories that are importing the request package. This is actually probably significantly less than reality, because this is the way that this number is calculated requires that the dependency be used in a particular way, or one of a subset of ways. And so to wrap things up on what software dependencies are, if you've ever done a pip install, poetry install, so those two are both for Python. There's also conda, and then for JavaScript, we have npm or TypeScript. For Ruby, we have gem install. Then for Java, Kotlin, we have Maven. Go, we have GoMod. There's pretty much one for every language. Some share with other languages. Like I said, Java and Kotlin both use Maven. I believe C# can also use Maven in certain instances. That world gets a little fuzzy, but for the most part, Python, you're either using pip, poetry, or conda. JavaScript, npm. Npm is actually probably, I wouldn't say my favorite, but it has a lot of capabilities that I really enjoy. Even just like npm audit, for example, which is kind of a high level software supply chain tool. And so if you've ever used one of these, you've used a dependency before. So some quick fun facts about dependencies. PyPy specifically hosts almost 500,000 packages and over 5 million releases. And so these are all open source. There's also organizations have internal or organizational packages, of course, that they maintain internally that their developers can directly reference, but those wouldn't be included in this count. If you think 500,000 packages is a lot, you should probably take a look at NPM, which has probably about 5 times as many, and who knows how many releases. I haven't actually ever looked at that number. If you are ever trying to hack Roblox, be careful when using npm packages, because for whatever reason, there are thousands, if not tens of thousands, of Roblox malware packages hosted on npm. There's also a lot of good, but also bad publicity about how npm reviews packages before hosting. So a lot of interesting information out there on the web if you're curious on how they kind of ingest packages, how they host them, and make them available to all the end users. And in general, 98% of all applications use at least one open source dependency or software. This number was kind of shocking to me just because my background so focused on InfoSec at financial institutions, which is heavily regulated. And a lot of those organizations don't have more than one full-time developer, let's say. And so when they hear open source, or if management hears open source, it usually shut things down pretty quickly. They'd honestly rather pay just to have the ability to say we don't use open source, which is an interesting take, which I'm sure a lot of you can understand if you're at an OWASP event. So, and this last one here, this came from a GitHub report that was published in 2020. So JavaScript projects with an average of 10 direct dependencies had on average 683 total dependencies. So back when I was talking about direct versus transitive, third, fourth, fifth party dependencies, this report showed that if you had just 10 direct dependencies, there's apparently an average likelihood that you'll have a total of 683 total dependencies. So that'd be 673 transitive dependencies. Of course, different direct dependencies will use different amounts of transitives. You might find the beautiful direct dependency that doesn't rely on any dependencies. That would be like fantastic for software supply chain security, because then if you have a vulnerability, and there's a fix for it, all you got to do is upgrade to the fixed version, and you're done. Remediating transitive supply chain vulnerabilities is an interesting undertaking, and we can kind of touch on that a little bit later. And then there's dependency hell, which the dumpster fire, classic InfoSec, or just really security logo, I would say. Everything good has its downsides. Managing dependencies can get very messy very quickly, especially if you're like me, and back when you're doing a lot of penetration testing, red teaming, script kiddie acts, you find a script on GitHub and you do pip-r requirements, and you just pip install -r requirements, and all of a sudden you're installing all those dependencies to your local environment as opposed to a virtual environment. And then you go get a different script, and you see that it uses the same dependencies. So you don't need to install it again because you already have it. But then you find out that you have the wrong version. So these analogies here, too many cooks in the kitchen. You just have too many people who are telling you what to do and they're all trying to get the food out the door. And when you run into that, it's a dumpster fire. And the clash of updates is an interesting one because, like I was saying, when there's two applications that might rely on the same dependency, if the versions aren't compatible, then you run into issues. So you might think to just install the latest version and everything will be a-okay. But oftentimes versions will be specified or locked at a certain version, which requires you to then do pip install the package name and specify the version. Got the classic memes. So definitely want to avoid manually installing software dependencies, especially without checking compatibility. That's just going to be a nightmare. You'll wind up installing everything. Or you can just use a package manager to handle dependencies and avoid conflict altogether. So that leads us into build reproducibility, which some notable benefits. It works on my machine syndrome, which if you're grabbing a lot of scripts or applications from things like GitHub and you're wondering why it's not working on your machine, well, that's because build reproducibility likely wasn't a thought for the developer who published it. I'm not saying that READMEs shouldn't have steps to go through the build process. I think that's great. But by using things like virtual environments or now with Docker, those two things make life so much nicer. You can actually just, there's nothing better than something just working. That's how I like to put it, at least. And so using tools like requirements.txt, which would be the classic Python solution, or virtual environments where you can use things like pip file locks, or just pip files, poetry lock files, and things of that nature. And this also prevents updates from altering the build unexpectedly, which often referred to as dependency drift. So if you're updating and maybe not managing your dependencies for your project, and you're not using or not following build reproducibility practices, you might find out that your dependencies are no longer the correct versions for what you're trying to achieve. And I put the please care about this because it really, without this, supply chain security goes out the window. There's only so much you can do from a security engineer's perspective or security researcher perspective if the developers themselves aren't taking the right approach to follow best practices. So some more insight on virtual environments, specifically pipenv. And so it's really just think of it like an isolated environment. If you're familiar with pip, you may also be familiar with virtual env, which historically you can use them together to kind of achieve the same solution as pipenv. Or you could just use pipenv, and again, life will be easier. I'm all about making life easier. And so it ultimately just
I think you have a question. You don't?
Okay. Sure thing. Is there a way for, I don't know, I might not be looking in the right spot.
Okay. I thought I heard someone speaking to ask a question, but
Cool. Cool. Well, if you do have a question, feel free to speak up. We got plenty of time. Alrighty. So yeah, with pipenv, you can automatically create these virtual environments, and you can add, remove packages as you'd like. You can also update them. You don't really need to specify the transitives. It'll do that for you. And yeah, you could also specify version ranges. So say you want to support all minor version upgrades with your direct dependencies, you can specify that. So then when future developers are trying to reproduce your build, they don't necessarily have to use the outdated package that you relied on initially. If there's a newer minor, maybe there was a minor fix, they can use that latest version. And so I can't tell you how many times I've done the bottom one here, just pip install something. I would strongly encourage you move away from that practice if it's something that you're used to. And this was probably something that I did 100 times, just like trying to run a script, getting the error message, no module named requests, Googling what that means, and then pip installing it, and then finding out I'm missing another one, and then another one. And it's just an endless cycle. So I do have a quick demo that we could walk through specifically for pipenv. Not sure, let me know if we need to make this a little bigger. You able to see that okay?
Yes.
Cool. So yeah, I'm just gonna clone a package real quick, and then I'm gonna go into it and show that it has a requirements.txt file. So that this is actually from it's project created about 5 years ago. And so a lot of these virtual environments or pip file or pipenv, for example, wasn't common practice. I don't even know if it existed 5 years ago. But you can see here that it's specifying what dependencies that the project requires. And you can also see the comments where it says via and these are the transitive dependencies. So you actually don't need to specify the transitives in a requirements.txt, at least not if you're using something like pipenv. So what I'm going to do next is just get rid of this. And I'm going to show you how, if you had a project, you can actually create a requirements.txt file using something called pip reqs, or pip, it stands for pip requests, or requirements, sorry. So that'll generate a new requirements.txt file, which you can see has those same direct dependencies, just without the transitives. And then I'm next going to use pipenv install to leverage that requirements.txt file, but initialize a pipenv environment. So it's going to create a virtual environment. It's going to install those direct dependencies. It's also going to determine what transitive dependencies are required. And then you should be all good to go. It'll generate a pip file and also a pip file.lock. So that pip file is where you can specify things like version ranges. Right now, this is requiring specific versions, but it can be updated to allow either minor, major, or however you'd really like. There's also dev packages. So you can, as a developer, you can specify packages that might be required only for development and what might be required for production, which plays a big part when it comes to software supply chain security. And then so you can see the pip file was very straightforward. The pip file.lock has a lot more to it. It goes into the breakdown of direct dependencies, transitives, all their appropriate hashes. And really, this is what Semgrep supply chain, for example, really leans on to understand what dependencies are in your project so that we can determine what vulnerabilities might reside. So next I use the pipenv graph command, which gives you a nice pretty little graph breakdown. So you can see the direct dependency, and then you can see the transitive dependency, so the third party, and then you can also see the fourth party and the fifth party. And if you had done this on a larger project, you would see that, or if you just got lucky with a certain dependency, you could see that these chains can be significantly long. An interesting research project that I hope to do sometime in the future is evaluating what the risk might be as you go down that chain. So we'll get into reachability using software composition analysis, which ultimately determines is the vulnerability actually used in your code base. And so with transitive reachability for transitive dependencies, you can determine, is that third party package actually using the vulnerable function from a fourth party dependency? If that's a little confusing now, that's fine. Hopefully we'll clear it up as we get into that section of the presentation. Let's see. So some interesting information on vulnerabilities. So in 2021 alone, there were over 20,000 CVEs. This number is growing like crazy. I could have sworn I read something this morning that we're gonna like double the amount of CVEs from last year in 2023, or maybe we're on pace to double them in 2024 or something like that. I don't know. But if you look at the latest data, it's definitely obvious that the amount of CVEs being reported is growing significantly, especially supply chain. There's I don't want to call it a debate, but I've definitely received and seen multiple answers in that if you have a project with a vulnerability and it's a dependency, and then there's 5 other projects that use the vulnerable component of that dependency, does that then mean there's 6 CVEs or is there 1 CVE? So it can be kind of debated either way. But if we're not going to count them all as CVEs, we need a way to better notify end users that there's a vulnerability, because a lot of people only look at vulnerabilities when and if they're assigned a CVE. I wouldn't recommend that. And if you're thinking, well, there's 20,000 CVEs, but there's X amount of programming languages. If you're using any of the common ones, there's likely thousands of relevant vulnerabilities each year. And the scary part, in a survey, half of the organizations had only 15% of open vulnerabilities remediated. On the supply chain side, a lot of people don't use a supply chain tool to even identify vulnerabilities and dependencies. Some people don't even know to think about that. And that's kind of what I'm really pushing to spread. To be frank, I am familiar with things like the Verizon report. I do know that 95% of incidents are going to involve some form of social engineering and not a vulnerability caused by a dependency. But I am also somebody who really likes perfection, and I don't like vulnerabilities in my code. But that brings me to only 2 to 4% of vulnerabilities are high risk. And so specifically, high risk in this example is going to be vulnerabilities in dependencies that can be exploited and are used in the first party code. So of those 20,000 CVEs, for example, there's probably a large subset that say vulnerable if you use this specific function, or vulnerable if you use any of these functions. Sometimes they don't say that, but it's implied if you look at the patch or reverse engineer the patch, which is what our analysts and security researchers do at Semgrep on the supply chain team. But you can often determine what particular functions trigger that vulnerability in your code, which shockingly tends to only be, at least in the examples that we've seen, typically only 2 to 4% of supply chain vulnerabilities are in fact reachable in their code. And so how we do it at Semgrep is really broken up into 2 steps. And so we scan the lock file to get information, which I showed you the pipfile.lock, for example, earlier. And so we'll take all that information and we'll determine what dependencies your project uses, what transitive dependencies. We'll parse all that out. We'll get their version numbers, and then we'll use Semgrep's open source engine, which is the static code analysis tool. So we'll use that as a software composition analysis tool to search for code that exercises the vulnerability within the package. So the heavy lifting that our supply chain research team does is really reverse engineering and investigating every CVE or security advisory that impacts an open source dependency. So we're digging into those. We're determining what vulnerable functions there might be. We'll also look to see what internal functions rely on that vulnerable function to make sure that we're getting the best coverage possible. And yeah, so we have plenty of time. So I figured I'd go into Semgrep a little bit. Like I said, Semgrep supply chain relies on the open source engine. And so this would everything I show you is available either via the open source project, or we also have the entirety of everything we offer at Semgrep is free for up to 10 contributors. So if you're using it for private projects or private repositories, there can only be up to 10 contributors before it flags and notifies us to have a salesperson basically knock on your door. But what's interesting is public repository contributors don't count towards that. So you can actually use the entirety of Semgrep for entirely free for all public projects and repositories. So if you're a security researcher and just want to see what evaluate supply chain vulnerabilities on open source projects, or even use the static code analysis tool with the pro rules, you can do so. And so really, I guess I'll walk you through what an analyst kind of does on a daily basis. Say there's a new vulnerability, and for this example, it's the pillow package, which is hosted by PyPy. And so you can see here that the pill.imagemath.eval function in pillow before 9.00 allows evaluation of arbitrary expressions, such as ones that use the Python exec method. So this advisory is very friendly. It gives us a proof of concept. The analyst or researcher would then look through the patch and then evaluate any other internal function calls that may indirectly trigger the vulnerability. But in this case, let's say we've already done that and we determine that it's just this imagemath.eval function that is actually vulnerable or triggers the vulnerability. And so what we do with the supply chain product is, after parsing that lock file and things of that nature, we can then determine what rules to run against what dependencies. So say, but for this example, we're just going to ignore the version number specifically. But if you knew that, say, this code relied on a known vulnerable version of Pillow, you can then write a Semgrep rule. And so if you haven't used Semgrep before, definitely encourage you to check out the playground. Very, very simple to pick up. I never used Semgrep before joining Semgrep, and within a month, I was writing relatively complex rules, which was pretty awesome for research because you can really run this thing at scale. Code doesn't need to build. It's really just it just works, which is the thing that I mentioned earlier I love most. So here we just set an ID. We have a message to notify whoever's running Semgrep if this rule triggers. Can print out a message specifying the language. Severity is just a warning in this case. And there's plenty of documentation on the Semgrep site to detail what these fields are and what other fields you might be able to add. But we have a very simple patterns here, so it's going to do a pattern inside. So it's looking for import pill, which right here, you can see the from pill import image chops, image math. It's worth noting that Semgrep stands for semantic grep. So similar to grep, we're searching for pill, but we're also using the semantic piece, which we're not calling. The pattern isn't for from pill; it's import pill. But the software composition analysis tool knows that it's more or less the same. So it's not like grep where everything has to be exact and you don't have to use regex, for example. It's just smart enough, and it's smarter with some languages than others. And then similarly, we have a pattern for, well, let me just show you, if you highlight that out. So it's identifying the import pill, and then I have this ellipses afterwards, which is going to say after import pill, match everything else. So that's why everything's highlighted. But we know based on the advisory that we only care about this imagemath.eval. So we can write a pattern in addition to the pattern inside to look for that specific function call. So we should expect a highlight here. Notice how it's adjusted image equals imagemath.eval and not pill.imagemath.eval. Again, the semantic piece is just smart enough to differ or differentiate. So if we hit run, you can see that it matches that specific function call. So you can imagine at scale, you can really identify actual vulnerabilities in code very simply, both for this as like a SaaS solution, which is what it was originally intended for, and now also for supply chain. Before I hop off of the playground, any questions about just general usage of Semgrep, whether it be supply chain or SaaS? Cool. And I'll get into the dashboard a little bit. So again, this is where the product that Semgrep offers resides, which recently now also includes the secrets solution, currently in beta. But I do have this open source project I think it's CodeMD. I honestly don't remember what it does. But I just ran Semgrep against it out of curiosity because I wanted to know what potential vulnerabilities it may have. And so this is the latest version. I ran it, and there's 6 reachable supply chain vulnerabilities. But if you look here, there's also 46 unreachable. So that means that Semgrep supply chain has written a rule for 46 security advisories or CVEs, and the pattern did not match in the code base, which means it more or less your project isn't vulnerable to them. So if you're a security engineer or working at even a developer who just cares about supply chain, you now don't have to worry about 46 vulnerabilities. You can just ignore them, which obviously saves a lot of time. And then for those 6 reachable ones, you can go through them. The analysts write advisory messages. This one is a manual review, so it requires that it says here, reachable if you utilize Markdown PDF to convert a Markdown file to PDF, or reachable if you host a public-facing engine.io server. This Babel vulnerability seems to be impacting everybody, but it actually only impacts you if you're using one of these known plugins or a third-party plugin that relies on path.evaluate. But then we also have the code scanning reachable findings. So you can see here that it's reachable via 2 usages, and you can simply click the little link and it brings you right to where it's vulnerable. If you're using this on your own project, you can get, it can generate commit messages or PR messages. It just bakes right into your CI/CD. Yeah, I hope to leave roughly 15 minutes for questions. So I guess we can open it up. I got to show you yeah.
No question, anyone? Going once, twice? All right, sold. Kyle, we definitely appreciate you joining us. There's any like last minute contacts, how can people reach out to you if they do have any questions afterwards?
Well, you can reach me either email or LinkedIn. My email is just kyle@semgrep.com, and LinkedIn, Kyle Kelly. Hopefully somewhere close to the top of that search. I try to post as much as I can. So
perfect. Well, we definitely appreciate you coming to OWASP Atlanta, sharing your knowledge and introducing Semgrep and especially supply chain, for supply chain analysis. So that's definitely appreciated. I did learn some stuff. I've been meetings actually dive a bit more into Semgrep. So this is great for me.
Hey,
especially.
I've got a quick question. Something you mentioned earlier about transient dependencies, and I see this a lot. Especially you were mentioning npm package and a lot of the Python packagement. There is this idea that if there is a vulnerability anywhere in there, that affects our environment. And I've seen a lot of teams waste a lot of cycles trying to identify, prioritize, rank stack, do all the fun stuff. Does Semgrep, or are there any other tools out there that kind of look at the kill chain, if you will, and determine if a vulnerability really is in line for a specific resource or a specific service in the way it's run, or a specific module that's being used for the development of that? Is there anything that you know of that helps kind of cut through some of that?
So it's actually something that we're actively working on, which I'm really excited about. Currently, our customers tend to have just so many vulnerabilities that we can safely say hey, just focus on direct dependencies with reachable vulnerabilities, particularly those that are critical and high, because they might have 10,000 vulnerabilities or thousands of vulnerabilities. And so even narrowing it down to just that subset is plenty of work for the security engineers or developers to work on. But we are working on transitive reachability and just kind of more depth presentation around the kill chain specifically, because that opens the doors for things like what I've been referring to as like the domino effect, where we can say, hey, Mr. Security Engineer, like if you just upgrade this one package, because of the transitive dependencies and all their vulnerabilities, you can remediate 20 or 30 vulnerabilities by just upgrading this one. So that's why I think it's super important to focus on that. And as I mentioned earlier, I'm also really excited about further research on how far down the kill chain do those vulnerabilities even matter? Because I suspect it's less than what people might think.
Yeah, I mean, I anecdotally can share the same experience. It's a lot less than people think, especially if you have a compensating control and, like you said, remove the right domino, then the overall effect is nullified by a number of other controls. A lot of access management type stuff, RBAC, and all the other good stuff. Do you have a timeline on, you guys are working? You said you guys are working on this now. Is that the roadmap 2024 item or something?
I want to say it's either this quarter or next, so hopefully very soon.
Okay, great. Yeah, I'll definitely be looking for that.
Awesome.
Well, thanks, Scott. Any last questions? Definitely have the time to ask it right now.
This was great. Thanks a lot, Kyle.
Of course.
All right. Well, thank you so much for joining us, Kyle. And thank you to everyone that attended. Definitely glad for you to participate. We'll be posting up the recordings, I don't know, in like a couple of days from now. So for folks who weren't able to join, coworkers and people in the industry, we definitely will provide that. Sam, I'm on. No, we can't hear you, Sam. Are you trying to ask a question? Okay, definitely maybe type it. I think we unmuted you.
The anticipation.
No.
But we wait for that. I would mention Andy Lewis, Reversing Labs, beautiful supply chain stickers. Very much.
Yeah, brother. They are awesome. Thank you for the plug. The functionality is even better than the stickers. So, but I really enjoyed your presentation here. This was good stuff.
Thank you.
Yeah.
I love the work you guys do.
Yeah. Thanks, man. Likewise. Oh, come on, Sam. Type. There you go. Yeah, there we go.
Let's see. For the finance industry, the dependencies are built from scratch. Even simple GET posts that would have been implemented using libraries. So yeah, I mean, I have seen that. Or what those that have established dev teams that actually are developing things of importance. Those that I say are not allowed to use open source dependencies at all or any open source software, they're typically doing, when I say programming, more so refer to things like SQL programming or just like report generation, ServiceNow integration, stuff like that. So they have a lesser need for those open source software dependencies. what some of the more secure institutions do, say if you're a Google, you're likely forking packages that developers are heavily reliant on, and then maintaining those in-house. Hopefully that answers the question. I should have mentioned the financial institutions I work with are not your Bank of America's or Chase. They're more community banks and credit unions. Yeah, don't be too worried. I usually advocate for most of the clients on the financial industry side to just not do development. If you can't invest in it properly, you should probably stay away from it.
All right. Any last questions? Okay, I think we can call it quits for tonight. Thank you so much, Kyle, for joining. Currently, we don't have any talks or meetings planned for next month. We might be planning a social, keep out for that. But for the most part, hope to see y'all next year. Thank you for joining. Goodbye, everyone.
Thanks,
Thanks,
y'all.
everyone.
Good job, Kyle.
Thanks. Have a good